Hi and welcome back to Mathalino, where we teach you tips and tricks in mathematics. And for today's video, we will define an arithmetic sequence and series, get the nth term of an arithmetic series, and get the arithmetic means of a sequence. So first up, let's start. What is an arithmetic sequence? Arithmetic sequence is also known as arithmetic progression, wherein a constant is added to the previous term to get the next term. We call this constant difference or the common difference, which we denote by D. So for example, dito we have 0, 2, 4, 6, 8, and 10. We just add 2 to get the next term. So D is equal to 2. So 0 plus 2, 2, 2 plus 2 is equal to 4, and so on and so forth. So as you can remember, meron tayong a sub 1, a sub 2, a sub 3, and then as I mentioned earlier, we just simply add D to get the next term. So for example, if we will get a sub 7, we will have 10 plus 2, and a sub 7 or the 7th term is 12. Now here we have 3, 9, 15, 18, 21, and 30. Now, how do we get the next term? I will give you guys 5 seconds to think. And the answer is, we cannot get the next term because an arithmetic sequence needs the constant difference. So 9 minus 3 is 6, so 3 plus 6, 9, 9 plus 6, 15, but then 15 plus 3 is 18, so we don't have a common difference. Next, we have 5, 10, 15, 20, 25, and 30. As you can all guess, these are multiples of 5. So we can assume that our constant difference is... Nice one! The constant difference is 5. And this is also an arithmetic sequence because it has a common difference. So we can have 5 plus 5 is 10, and 10 plus 5 is 15. Now, for each arithmetic sequence, identify the first term, common difference, and the next term in the sequence. Let's try this. 2, 5, 8, and 11. So our a sub 1 is 2, and our difference is 3. How did we get 3? 5 minus 2 is 3. 8 minus 5 is 3, and 11 minus 8 is 3. So 11 plus 3 is 14, and therefore 14 is our next term. Here, try this one. Alright, so here is our answer. Our a sub 1 is 1, and our common difference or constant difference is 1/3. Our next term is 2 and 2/3. Try out this one next. Alright, so our a sub 1 is 17. And then 12 minus 17 is negative 5. So that will be our D. And then our next term is negative 8, since negative 3 plus negative 5 is equal to negative 8. Next, let's learn to derive the nth term. Deriving the nth term is basically the general rule. So let us have the sequence 1, 3, 5, 7, and 9. I apologize for the typo in advance, but this will be our sequence. And then our D is 2, positive 2, since 3 minus 1 is 2, 5 minus 3 is 2, and 7 minus 5 will be equal to 2. Now we have this formula for getting the nth term. So first we have our a sub 1 is equal to a1, a sub 2 is equal to a sub 1 plus d, a sub 3 is equal to a sub 2 plus d. Basically, previous term plus d is the next term. So this is what we call the recursive definition. And then we have the formula, which is a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. This is the formula for the nth term or of an arithmetic sequence, or basically how we get the general rule. So let's have this example. A company offers Jeffrey a starting salary of 300,000 pesos with raises of 24,000 pesos per year. What will his salary be on the 10th year? Now, using the word problem, let us first identify our given. What is our a sub 1? Our a sub 1 is the first term in the sequence. So here, our a sub 1 is the 300,000. This is the first term since we start with this salary, so it's 300,000. Next, that is easiest to find is our D. Now our D is 24,000 per year since this is the rate of how much they raise his salary per year. So D is equal to 24,000 since they have 24,000 as a raise per year. Next we have our N, which is 10, since this will be the number that we will be looking for. So remember, A sub N is different from N. So let us have the solution. A sub N is equal to A sub 1 plus N minus 1 times D. And we plug in our values, so N equals 10. So A sub 10 is equal to 30,000 plus quantity of 10 minus 1 times 24,000, which we have 9 times 24,000 plus 30,000, and we will get 516,000. So this is not our final answer since we will write his final salary in 10 years will be 516,000 pesos, or you can use total salary as well. Next, let us find the 10th term of the sequence 1, 5, 9, and 13. And like I said before, let us always begin with getting our A sub 1. Our A sub 1 in this sequence is 1. It is the first term. Next, we find the D, so 5 minus 1 is 4, 9 minus 5 is 4, 13 minus 9 is 4, so we can say our D is 4. Next, our N, or what we are looking for, here it says find the 10th term, so our N will be equal to 10. Let's plug in our values to the formula. So we have A sub 10 is equal to our first term, 1, plus the quantity of N minus 1, or 10 minus 1, times 4. So 9 times 4 is 36 plus 1, 37. Let's make the numbers bigger. Find the 20th term of the sequence 25, 23, 21, 19, and 17. Regardless of the sequence, our process will still remain the same. Let us find our A sub 1. In this sequence, we have 25 as our A sub 1. And then let us get our D. 23 minus 25 is equal to negative 2. 21 minus 23 is equal to negative 2 as well. And then we move on to our N. Our N is 20 since we are looking for the 20th term. Now, after getting our A sub 1, our D, and our N, we can now plug all those values into our formula for the nth term of an arithmetic sequence. So we have A sub 20 is equal to 25 plus 20 minus 1 times negative 2. So our A sub 20 is equal to 43. Next, let us derive the nth term. So finding or deriving the nth term is basically getting the formula to find any term in a given sequence. For example, find the nth term of the sequence 3, 7, 11, and 15. Remember, n is different from nth term. N, we're looking for a term, but in nth term, we are looking for the formula or the general term. So here our A sub 1 is equal to 3 and our D is equal to 4 since 7 minus 3 is equal to 4 and 11 minus 7 is equal to 4. We basically plug this into the formula for the nth term of an arithmetic sequence. So A sub n is equal to 3 plus the quantity of n minus 1 times 4. And then we multiply by distributing 4, so 3 plus quantity of 4n minus 4 will give us 4n multiplied by the quantity of 3 minus 4, so that will be 4n minus 1. We did this by combining similar terms. Now let us test this. A sub 1 is equal to 4 times 1 minus 1. A sub 1 is equal to 4 minus 1. A sub 1 is 3. And it checks out since our first term in the sequence is 3. This will also check out if our second term is 7. So 4 times 2 is 8 minus 1 is 7. This means that we derived the correct nth term and we got the correct general term. So let's find the nth term of the sequence 2, 8, 14, and 20. And again, we only have to identify two things, the a sub 1, and d. So here our a sub 1 is equal to 2. And our d, 8 minus 2 is 6, 14 minus 8 is 6, 20 minus 14 is 6. Therefore, our d is also 6. Same thing as the previous, we plug it into the formula. So 2 plus the quantity of n minus 1 times 6, we'll get 2 plus the quantity of 6n minus 6, and then we combine like terms to get 6n minus 4. Now we can also use this formula to find what term a number is in a sequence. So let's try it out. In the sequence 50, 45, 40, and 35, which term is 5? So let us again get our given first. So our given is a sub 1 is equal to 50, and then our d is equal to negative 5. Now we can plug this into our formula. We put 5 in the place of a sub n since we do not know which term is 5. So 5 will be equal to 50 plus the quantity of n minus 1 times negative 5. We then distribute and multiply. 5 is equal to 50 minus 5n plus 5, and combine similar terms. We transpose 5n to the other side, and then we compute. 5 minus 5 is 0, so we divide both sides by 5 to cancel it, and we will get that n is equal to 10, meaning 5 is the 10th term of this sequence. Next, we have in the sequence 7, 10, 13, and 16. Which term is 43? So again, we will get our given and then substitute it to the formula. Our a sub 1 is 7, our d is 3, and then we plug it in. 43 is equal to 7 plus the quantity of n minus 1 times 3, and then we distribute 3 and combine similar terms. Negative 3n is equal to 7 minus 3 minus 43, so we get 4 minus 43, which will give us negative 39. And then we divide both sides by negative 3 to cancel out n, and therefore we will get n equals 13, so 43 is the 13th term of this sequence. Next up, we have arithmetic series. So arithmetic series, like in the sequence series video, is the sum of arithmetic sequence. So we have two simple formulas for operating with arithmetic series. If an is given, or a sub n is given, we have s sub n is equal to n over 2 multiplied by the quantity of a sub 1 plus a sub n. And if it is not given, s sub n is equal to n over 2 multiplied by the quantity of 2 times a sub 1 plus the quantity of n minus 1 times d. Now let's try this. Find the sum of the first 12 terms of an arithmetic sequence: 50, 47, 44, 41, and 38. Here, we do not know the value of the 12th term in the sequence. Hence, we will use the second formula. First, we of course identify our given. The first term is 50, and then our d, or common difference, is negative 3, and our n, or the amount of terms, is 12. So we plug it in, we will get s sub 12 is equal to 12 over 2 times 2 times 50 plus 12 minus 1 times negative 3. We then simplify to get 6 times the quantity of 100 minus 33, which will give us 402. So the 12th term in this sequence is 402. Next, let us find the sum of the first 300 natural numbers. Here we know that our last number is 300 and our first number is 1. So we can use the first formula, which is s sub n is equal to n over 2 multiplied by the quantity of a sub 1 plus a sub n. So our first term is a sub 1, or 1, and our n is 300, or the amount of terms. So we can use s sub 300 is 300 divided by 2 multiplied by the quantity of 1 plus 300, which when simplified gives us 150 times 301, and hence 45,150. We now move on to the arithmetic mean. Arithmetic mean is basically the average of all terms in an arithmetic sequence. But here, since we are talking about sequence and series, it does not just mean the average, but it also means any terms between two numbers in a sequence. For example, Dominic's grades for the first quarter are 94, 90, 96, 93, and 95. What is his general average? So we can do this by summation notation. The arithmetic mean is equal to the summation of all terms divided by the amount of terms, or summation of x divided by n. 94 plus 90 plus 96 plus 93 plus 95, and then we divide it by 5. All of grades added will give us 468, and then to get the arithmetic mean, we divide it by the number of terms, which is 5. So 468 divided by 5 is 93.6. Therefore, his general average will be 93.6. Next, insert 3 arithmetic means between 18 and 30. So again, arithmetic mean can also mean any terms between 2 terms in a sequence. So our a sub 1 is 18 and our n is equal to 5. How did we get 5? We have 5 terms in this sequence. Now we plug in into the nth term formula to get a sub 5 is equal to 18 plus 5 minus 1 times d. Then we put our last term 30 and equate it to the first term plus the quantity of n minus 1, which is 5 minus 1 times d. And then we again combine like terms and perform transpose. So we get 48 equals 4d, and then divide both sides by 4 to cancel out the similar terms. Hence, we have 3 as our d. Now that we have the common difference, we can say that the next term after 18 is 21, since 18 plus 3 is 21. And then 21 plus 3 is 24. This will be our next term. And then 24 plus 3 is equal to 27. These will be our 3 arithmetic means between 18 and 30. We can verify since 27 plus 3 is equal to 30. Let's have this next one. The arithmetic mean of 2 terms in a sequence is 42. One term is 30. Find the other term. So we know that this is the formula. X sub 1 plus x sub 2, or basically the 2 terms, since we have 2 terms, divided by 2 is equal to our arithmetic mean. Now, how do we get this? We substitute. 30 plus missing number divided by 2 is equal to 42. Now, we perform cross multiplication. 42 times 2 is 84. 30 times 1 is 30. So 84 equals 30 plus x sub 2. And then we combine like terms, and 84 minus 30 is equal to x sub 2. Therefore, our other term, our missing term, x sub 2, is equal to 54. Now, before we end, let's have a quick recap of our concepts. An arithmetic series or progression is a sequence wherein d exists, or the common difference. The nth term is the general rule denoted by the formula a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. An arithmetic series is the partial sum of the first n terms of an arithmetic sequence denoted by s sub n. We have 2 formulas. If a sub n is given, here is our formula. And if a sub n is not given, this is our formula, which is basically an expanded form of the nth term formula. Lastly, an arithmetic means is basically the average or all the terms in between any 2 terms. So thank you for watching. Feel free to message us on all our social media profiles, and good luck!